So let's do section 5.8. We're going to solve polynomial equations by factoring. And this is a really important part. Many students, when they're asked to factor a polynomial, they will try to solve for x. But a polynomial doesn't have an equal sign. When we do have an equal sign, when we have one polynomial set equal to something else, which might be another polynomial, then we have what's called a polynomial equation. And the important part is an equal sign is included, and the word solve for x is mentioned. So when you're factoring a polynomial, think about what you're doing. You're factoring a polynomial. You're writing a sum of terms into a product of two or more terms. When you're solving a polynomial equation, you're solving for x. You're going to give me a value or values of x which make the equation true. The point being here, we're going to be solving degree 2 polynomials. Not linear polynomials, like x plus b is equal to c. Those are really easy. Those are how we started the class off. Now we've graduated to degree 2 polynomials. So we'll read what's in the box. A polynomial equation is the result of setting two polynomials equal to each other. A polynomial equation in standard form is an equation where one side is 0. So we'll always want to put our polynomial equations in standard form. And a degree 2 polynomial equation is called a quadratic equation. And here is going to be the very property that we use again and again and again. It's a very important property in all of mathematics. It's called the zero factor property. So for any real numbers p and q, we have if p and q, p times q is equal to 0, if and only if at least one of p or q is 0. So just remember, if I have the product of two factors equal to 0, at least one of them has to be equal to 0. It could be all of them. And we can extend that. If p times q times r is equal to 0, then at least one of p, q, or r will have to be equal to 0. So the only way you're going to be able to multiply something and get 0 is if one of the factors is equal to 0. So here's how it's going to go. Here's our first easy use of the zero product theorem. So we have x plus 2 times x minus 6 is equal to 0. So we're going to solve for x. Why does this make sense? Because I have an equal sign. Well, I'm going to use the zero product theorem. It says if a, and I'll call this first factor a, times b, and I'll call this second factor b, and this is multiplication. If a times b is equal to 0, then a is equal to 0, or b is equal to 0. And that's exactly what I'm going to do. I'm going to take my first factor. I don't need to put it in parentheses because there's nothing on the outside of it like a minus sign. It means x plus 2 is equal to 0, or x minus 6 is equal to 0. And now literally all I'm doing is solving a simple linear equation, and that implies x is equal to minus 2, and this implies x is equal to 6. So my solution is more than one number. So my solution set contains minus 2 and 6. It's fine for me if you were writing on a test given to you by me in class, if you were to write x is equal to 2 or x is equal to 6. The or is important, and usually it's understood, but I'm pretty sure in my math lab they're going to ask you to enter the elements 2, and 6 in a solution set, and they may actually give you the curly braces indicating it's a set. So now, suddenly, pow, the simple case has disappeared, and we've got another case. So here is the thing. The only way you can solve this equation is to use the zero factor property. That means you have to factor. Now later on in college algebra, you'll get what's known as the quadratic equation. You're not going to get it in intermediate algebra. We must factor. So what this means is when you're given a polynomial equation in this class, in chapter 5.6 and all of chapter 5, it will be factorable. None of these will be prime. All of these will have a solution which you can determine. Notice that the greatest common factor is 1, so I can't use that observation at all. So I'm going to go ahead and factor. So I need a 2x squared. Since 2's prime, it's not so bad. Then I have my minus 5 and my 9x. So that's going to be 2x and x. And I'm just going to leave them that way. Now minus 5, well, one of them has to be 5, and the other has to be positive. So let's try minus 5 and 1. Minus 5 times 1 is going to give me minus 5. So it's going to give me minus 10x plus x. That's going to give me 9x, minus 9x. So let's change the negative sign. And I do this purposely so you can see this is really just a method of guessing and checking. If I just go through and I just produce the answers as if they were super easy, you might get frustrated because they're not so simple for you. And if they are super easy for me, it's because I've done them earlier. So 2x times 5 is 10x. X times minus 1 is minus x. 10x minus x is 9x. So my factorization is given by this. So that's the same as saying 2x minus 1 times x plus 5, because that's the factorization of this polynomial, is equal to 0. And now I'm into a place where I can use the zero factor property. That means either 2x minus 1 is equal to 0, or x plus 5 is equal to 0. This bottom one, the answer is immediate. X is equal to minus 5. Up here we just simply solve. 2x is equal to 1, which implies x is equal to 1/2. So our solution set contains two elements, 1/2 and minus 5. And just recall, sets are not ordered. 1/2 minus 5 is perfectly fine. Minus 5 first, 1/2 second. Sets are made up by their elements, not the order in which the elements occur. So there we have that one. So the trick here is going to be using our factors and our ability to factor. So here's a step-by-step guide. Write the equation in standard form. So standard form has 0 on the right hand or the left hand, it doesn't make any difference, and all of the variable terms and constant terms on the other side. Then we have to factor the polynomial completely. Remember, many times we'll have to check to make sure the given polynomial has the greatest common factor factored out. Set each factor containing a variable equal to 0. Solve the resulting linear equations. They'll always be linear. So here we go. These are all some good examples. So there's no way, it looks like it's easy to solve in this form. It's not. We can't solve it in this form. So we have x times 2x minus 7 is equal to 4. So let me give you the general form. We always want it in the general form. So when they say to put it in the general form, this is what that general form looks like. ax squared plus bx plus c is equal to 0. Now that doesn't mean b is positive or c is positive. C could be a negative number and b could be a negative coefficient. So in order for me to get it in the general form, so that's the general form from step 1, is I have to use distribution and then some other tricks. So x times 2x is 2x squared, and x times minus 7 is minus 7x. And I have that equal to 4. It's almost in general form, but I need to have a 0 on the right hand side. So I'm going to go ahead and subtract minus 4 from each side. And now it's in general form. I'm going to go ahead. So my a is 2, my b is minus 7, and my c is minus 4. So 2x squared minus 7x minus 4 is equal to 0. A is 2, b is minus 7, c is minus 4. I just wanted you to see this. We're not going to use it. So my only hope of solving this is to use the zero factor property. And factor the thing. So again, I have 2x squared minus 4 and minus 7x. So here I have to have a 2x and an x. Minus 4, let's do minus 4 times 1. So 2x times minus 4 is minus 8x. X times 1 is plus x. Minus 8x plus x is minus 7x. So I have all of my ingredients for the factorization. I just have to take the kitty corner. So this is equal to 2x plus 1 times x minus 4. And that's equal to 0. So now all I have to do is use the zero factor property. That implies 2x plus 1 is equal to 0, or x minus 4 is equal to 0. This bottom is extremely simple to solve. That implies x is equal to 4. And this implies 2x is equal to minus 1, which implies x is equal to minus 1/2. So our solution set here is minus 1/2 and 4. So let's do, maybe you should try number 4 on your own. Let's actually, before we do that, let's actually go into the original equation and let's substitute in 4. So this is my original equation, and I'm just going to go ahead and substitute in one of these. You can substitute in the other if you want, just to make sure we did it right. So 4 times 2 times 4 minus 7 is equal to 4 times 8 minus 7, which is equal to 4 which is equal to 4, times 1, which is equal to 4. So clearly 4 is the correct answer. And now let's go ahead and try x is equal to minus 1/2. So I have minus 1/2 minus 1/2 times 2 times minus 1/2 minus 7. Now let's go ahead and that's minus 1/2. 2 times minus 1/2 is minus 1 and minus 7. So that's minus 1/2 times minus 8, which is equal to 4. So both solutions check. I just want to make sure you understand that when you get a tentative answer down here, you can literally go back up to the original equation and check to see that it's correct. I know in an exam situation you rarely have time to do that. But here's the thing. Some of you work really, really fast. Well, and then you miss some questions. If you have all that time, go back and check your answers. Put an asterisk by any question that you might be uncertain, and for sure go back if you have time and check those. 3x plus 14 is equal to minus 8. Well, we just saw what we needed to do here. So x times 3x is 3x squared. X times 14 is plus 14x, and that's equal to minus 8. I need it in general form, so I get 3x squared. I'm adding 8 to both sides, and I'm good to go. I'm in general form. And just a quick check. The GCF of all three terms is 1, because when we're talking about a trinomial and one term doesn't have an x, the only question we have to do is what is the GCF of the coefficients. 3, 14, and 8, it's 1. So there's nothing else to do simplifying that way, but we do need to factor it. So this is where your factoring skills come in handy. And you need to be able to do this really fast. You can't tarry. And again, if some of you have a method of factorization that is different than this method and you're just as fast with it, then please use that. But if it takes you an awful lot longer to factor these polynomials, these trinomials in particular, then you should consider doing this. The cool thing about our degree 2 coefficient is it's prime. So I've only got one choice, 3x and x. Now 8, there's quite a few factorizations there, but whatever we choose, we want them to sum up to 14. So I'm going to do 8 is 4x times, 8 is 4 times 2. So 3x times 4 is 12x, and x times 2 is 2x. 12x plus 2x is 14x, so I have my factorization. So again, we go kitty corner for my factors. I don't really like that. I'm just a really fine, slim. So my factorization is 3x plus 2 times x plus 4. And it's really important that you remember to go kitty corner. I've had students who get all of this right and then they don't go kitty corner and they write 3x plus 4, x plus 2, and clearly that won't work. So now all we have to do is we set each factor equal to 0. So this is the 0 factor property. 3x plus 2 is equal to 0, or x plus 4 is equal to 0. The bottom one is super simple. That implies x is equal to minus 4. Up here implies 3x is equal to minus 2. So x is equal to minus 2/3. So my solution set is 4 minus 2/3. Okay, yet another variation on a theme. Again, you've got to realize in your heart of hearts, when you're given these on an exam, that all of them can be solved, and they can all be solved by factoring. It won't be until you get, unless I've got a bad memory, and you know I do already, but I'm pretty sure that you're not introduced to the quadratic equation until college algebra. So this is 3 times x squared plus 4 plus 5 is equal to minus 6 times x squared plus 2x plus 13. So what we're going to do again is just use the distributive property, and then we're going to collect like terms and simplify both sides, and then move all the terms to one side. So 3 times x squared is 3x squared. 3 times 4 is plus 12. And then I have a plus 5 already there. Don't forget that this is minus. Minus 6 times x squared is minus 6x squared. Minus 6 times 2x is minus 12x. And then I have plus 13. So we can simplify this side over here. This is 3x squared plus 17 is equal to minus 6x squared minus 12x plus 13. So I'm going to move all of the terms here on my right hand side over. So I have a 3x squared already here. When I move my minus 6x squared over, it becomes 6x squared. When I move my minus 12x over, it becomes minus 12x. Then when I move my 13 over, it becomes minus 13. And we can't forget that there's already a 17 there. So now what we need to do is we need to simplify. 3x squared plus 6x squared is 9x squared minus 12x, and minus 13 plus 17 is plus 4 is equal to 0. So we're going to do this one slightly different. I'm noticing something. I'm noticing my first term and my last term are perfect squares. 9x squared, the square root is 3x. So I was able to get rid of the radical. The square root of 4 is equal to 2. So what is plus or minus 2? That's the 2 I add times these two terms. Well, that's plus or minus. 2 times 2 is 4. 4 times 3x is 12x. And hey, I have a minus 12x here. So this is literally a perfect square. So it's 3x. Since it's minus 12x, I choose the minus. 2 squared is equal to 0. So wow, we just got to use something that we previously, I mean, you could factor it the other way. It might take a while, but that's the way I factored it. So here, the only point is just to remember that 3x minus 2 squared is the same as 3x minus 2 times 3x minus 2, and that's equal to 0. These factors are the same, so that implies 3x minus 2 is equal to 0, which implies 3x is equal to 2, which implies x is equal to 2/3. So in this case, I only have one solution, and it's x is equal to 2/3. Another really good example. So all of our techniques for clearing denominators are always going to work and work quite nicely when we have one side of the equation equal to 0. So all we're going to do with number 6 is we're going to first put it in standard form. That means I'm going to bring both terms that are on the right to the left-hand side, which means I write them in, I change their sign, is equal to 0. And now look what I can do. If I multiply both sides by 3, since 3 times 0 is still 0, I don't change anything, but I clear this denominator. So 3 times 1, that's the reason I chose 3, is because I have a denominator, one denominator, which is 3. So 3 times 2x squared is 6x squared. 3 times minus 17/3 x, I just cleared that denominator. And 3 times minus 1 is minus 3. Oh, that's much better to work with, isn't it? Now the GCF of 6, 17, and minus 3 is 1, so I can't do anything that way. So my only hope is to factor it. So that's what I'm going to do right now. So 6x squared minus 3 and minus 17x. So 6x squared, I mean, there's a lot of possibilities here. I'm going to start with the easy one, 6x and x. Minus 3 is prime, so I'm going to do minus 3 and 1. And 6x times minus 3 is minus 18x. 1 times x is x. So minus 18x plus x is minus 17x. That prime right there in the constant term really makes it easier. So my factorization is given by going kitty corner. And I've done that enough that you should be able to just look at it, remember, and say this is the same as 6x plus 1 times x minus 3 is equal to 0. And now we just use the zero product theorem. That implies 6x plus 1 is equal to 0, or x minus 3 is equal to 0. This bottom is easy. It implies x is equal to 3. The top implies 6x is equal to minus 1, which implies x is equal to minus 1/6. So we have a solution, minus 1/6 and 3. This one seems like it would be impossible. As a matter of fact, I thought, oh, I've got a typo there for just a small second. This is a good one. So many really excellent examples. I will commend Pearson this time for covering a lot of track. So x cubed is equal to 4x. So you're saying, crap, this is not a degree 2 polynomial. You're exactly right, but we're going to see what we can do. We're going to see if there's some kind of transformation we can do that will make it a degree 2 polynomial. because those are the only trinomials that you know how to factor, are degree 2 trinomials and binomials in the case of the difference of perfect squares. So I'm going to go ahead and put it in standard format. And now, here comes, always remember the GCF. So the GCF of x cubed and 4x is equal to x. So that means I can factor out an x. So x cubed divided by x is x squared. Minus 4x divided by x is minus 4. And that's equal to 0. Wow, I'm seeing another pattern. I know that 4 is 2 squared. So now all I have to do is I have to factor x squared minus 2 squared, and I know immediately what that factorization is. It's a difference of perfect squares. So that's x minus 2 times x plus 2. So remember, the x minus 2 times x plus 2 is what this is. And I have to bring down the x. So now I have 3 factors, but that's easy enough. This implies x is equal to 0, first factor, or x minus 2 is equal to 0. All of these are ors. Or x plus 2 is equal to 0. Well, the first one's already solved. X minus 2 is equal to 0 implies x is equal to 2. X plus 2 is equal to 0 implies x is equal to minus 2. So my solution set has 3 elements. X is equal to 0, x is equal to 2, and x is equal to minus 2. And in general, a cubic equation, the original equation was cubic, will have at most 3 distinct solutions, and here we have all 3 solutions. This one is going to be another weird example. I'm not quite as happy about this example as I am all of the others. And this is one of the downsides of choosing one method of factorization of trinomials and not teaching you 2 or 3 others. If I teach you 2 or 3 others, or at least one other besides that method, then students always confuse them, and it's just an utter disaster. I won't put something like this on the exam, but we're going to do it. So again, that x cubed is kind of already bugging me. But let's see what I can do. The first thing I do is I have to move my minus x over and my minus 5 over, and that's equal to 0. Now I'm going to notice, and here is the thing that you're going to notice. We have 4 terms. And we were able to factor 4 terms before by grouping. And that's going to be the observation that gets us out of this quandary. I'm going to group these here and these here. So what is the GCF of x cubed plus 5x squared? So the GCF of x cubed and 5x squared. Well, I don't have to worry about anything other than the x terms, and I take the x term of the lowest power. So I'm going to factor out an x squared. So x cubed divided by x squared is x. 5x squared divided by x squared is plus 5. Minus x minus 5 is equal to 0. Now before, I needed something else here. It would be good if I had a x plus 5 in parentheses. But if I have x minus 5, I can factor out what's called a minus 1. So I'm going to factor out a minus 1, and that's not a trivial factorization. So that's equal to minus 1, and then I just change the signs on each of my two terms, x plus 5. Here I specifically wrote a minus 1. So is there anything else I can do? Well, I have now reduced it to two terms. And when we did factoring by grouping before, those two terms have a greatest common factor. And in this case, that greatest common factor is x plus 5. So I'm going to pull out that common factor of x plus 5. So x squared times x plus 5 divided by x5 leaves me x squared. Minus 1 times x plus 5 divided by x plus 5 leaves me a minus 1. So I've got somewhere. At least now I can see that I can use the zero factor property on one factor anyway. X plus 5 will be set to 0. But now let's look at this degree 2 polynomial. That looks like, since 1 is equal to 1 squared, this is the same as x plus 5 times x squared minus 1 squared. And that's equal to 0. So my x plus 5, that's a linear factor, and it's actually prime. And I'm going to use the difference of squares factorization for x squared minus 1 squared. That's x minus 1 times x plus 1. And that's equal to 0. So I have three factors. So I said all three factors equal to 0. That implies x plus 5 is equal to 0, or x minus 1 is equal to 0, or x plus 1 is equal to 0. All three of these are easy to solve. This implies x is equal to minus 5. This implies x is equal to 1. And this implies x is equal to minus 1. So again, I have a degree 3 term, and I have three solutions. And that's as many as you will ever have when you have a degree 3 polynomial. And we started out with the degree 3 polynomial, then at most we will have three distinct solutions. So we still have a few more to do. This is a really important lecture with a lot of important examples. So we have the rocket problem. So an Alpha 3 model rocket is launched from the ground with an A83 engine. Without a parachute, the height of the rocket h, so the height stands for h, or h stands for height, at time t, so t stands for seconds, is approximated by the equation h is equal to minus 16 squared plus 144t. Find out how long it takes the rocket to hit the ground. This is a great example. I love this example. Not only because we live at the Space Coast and we have opportunities to see rockets launch all the time. And I don't know if there's any rocket launch aficionados out there. I try to watch all of them insofar as I know about them. And I do know about them because I have an app on my phone that tells me about them. And I've tried to see that Delta IV Heavy that's been canceled now, I think 6 times, scrubbed or literally put on hold in the last 7 seconds of the launch. And I don't know when it will actually make it up. It's carrying some super secret spy thing. So that's kind of cool. So this is the equation. Remember, h is equal to height from the ground, or height off the ground, and t is equal to seconds. So let's think about this. So without a parachute, the height of the rocket h at time t is approximated by the equation. I got that. How long does it take the equation to return to the ground? How long does it take the rocket to return to the ground? So my unknown is t. T is my unknown. And what is the height from the ground? Well, how long does it take the rocket to return to the ground? At the ground level, h is equal to 0. So we're literally solving 0 is equal to minus 16 t squared plus 144 t. So before we do anything here, let's consider something that should be staring us at the face. What is the GCF of 16 t squared and 144 t? Well, it's going to be, again a review, it's going to be equal to the GCF of 16 and 144 times the GCF of t squared and t. Well, I already know that the GCF of t squared and t is the smallest power, is just t. And what do I know in general about the GCF of 16 and 144? It's either going to be greater than or equal to 1, but less than or equal to what? The smallest of the two terms. So we can go ahead and factor. 16 is equal to, divide it by 2, and we get 8, not 4. I'm making my factor tree. So 16 is equal to 2 times 2 times 2 times 2. So 16 is equal to 2 to the 4th. So let's do the same thing for 144. Now you might realize 144 is 12 squared. So let's use that fact. It's 12 times 12. Well, 12 is equal to 3 times 4, and 4 is equal to 2 times 2. So again, we just circle. Well, 144 then is equal to 3 squared times 2 to the 1, 2, 3 to the 2 to the 4th. So what common factors do we have? Well, clearly that's our greatest common factor, which is 16. And that is actually the largest, that's the largest number it could possibly be. So I'm literally going to factor 16t out. So minus 16t squared divided by 16t is minus t. And 144t divided by 16t gives me 3 squared, which is 9t. So now let's move all of this stuff over here. So putting it all together, I have 16t times minus t plus 9t is equal to 0. So that means 16t is equal to 0, or I'll eventually get it. There's no t there. It's minus t. Or minus t plus 9 is equal to 0. So this gives me 16t is equal to 0. Well, by the zero product factor theorem, whatever it's called, 16 times some other number gives me 0. Well, 16 is not 0, so that means t has to be equal to 0. This implies 9 is equal to t. All I did is I moved the t to the other side and it became positive. So t is equal to 9. So I have two solutions. Only one of them can be correct. So let's model this by a picture. So here we have the ground. Maybe I don't want to make it. And I cannot draw, although I used to draw rockets all the time as a kid. Trust me, they were much better even as a kid. So we launch a rocket up, it goes up, and it follows a trajectory, and eventually comes down and hits the ground. So at this point right here, the rocket's on the ground. So that's the point t is equal to 0. Now as time starts ticking away, when we get 9 seconds later at t is equal to 9, we discover that the rocket has fallen back and hit the ground. So the answer to the question, how long does it take the rocket to return, that's the key word, is t is equal to 9 seconds. So, Pythagorean Theorem. So given a right triangle with sides A, B, and C and hypotenuse C, given a right triangle with sides A and B and hypotenuse C, right here's our picture, right there, that indicates that's the right angle. We have a squared plus b squared is equal to c squared. This theorem goes back to probably 500 to 1000 BC. How do we know that? The Babylonians, when we look at their clay tablets, they have what are called Pythagorean triples. Numbers like 3, 4, and 5. 3 squared plus 4 squared is equal to 5 squared. Huge lists of them. So we know that they knew about the Pythagorean theorem. And of course Euclid in the Elements, which was written around maybe 350 before the Common Era, proved the Pythagorean theorem. And I've literally got a book. I have a book somewhere in my library here. I don't see it. That gives like 150 proofs of Pythagorean theorem. So let's do and use that to solve this problem. and then we have some graphs to look at, and we'll be done. So while framing an addition to an existing home, a carpenter used the Pythagorean Theorem to determine whether a wall was square. A square wall means that it is at right angles, whether the wall formed a right angle with the floor. So let's kind of sketch our picture here. So this is going to be our wall, and this is going to be the floor. And that's our angle unknown right there. Is this angle actually 90 degrees? Well, we will know it if I know the measurement here is A and the measurement here is B. Then and I know the measurement of the diagonal C, if A squared plus B squared is equal to C squared, then the angle is 90 degrees. Actually, it's a more stronger theorem than that. The angle is 90 degrees if and only if that holds. So he used a triangle whose sides are 3 consecutive integers. So remember, integers are positive or negative whole numbers plus 0. But in this case, we're only dealing with positive numbers, so we're going to start with, they have to be positive. These are distances, so we don't have negative distances. So I'm going to let side A be equal to my first integer. What are consecutive integers? Numbers like 8, 9, and 10. They 113, 114, 115. One after the other. So A is going to be my first integer. Then B is equal to A plus 1. And C is going to be equal to B plus 1, which is A plus 1 plus 1, which is A plus 2. So A squared plus B squared is equal to C squared becomes A squared. What is B? A plus 1 squared. And what is C? A plus 2 squared. So here's my guiding equation. And here is, arbitrarily, I just said, let's let A be my smallest length. Kind of looks like it from the picture. Then B is going to be A plus 1, and C is going to equal to B plus 1, which is A plus 1 plus 1, which is A plus 2. So now all I have to do is solve this. So this is A squared plus A plus 1 squared is A squared plus 1 times A times 2 plus 1 squared, which is 1. Over here again, I'm using the special products formula for squaring. This is A squared. So I multiply 2 times A, which is 2A, then times 2. And then I square 2, which is 4. So now what I'm going to do is I've got to set all of these equal to 0, and something really nice happens. So let's first simplify both sides. A squared plus A squared is 2A squared plus 2A plus 1 is equal to A squared plus 4A plus 4. So I've simplified both sides, so now I have to put them in standard form. So 2A squared, I'm going to move my A squared term over, and it's going to become minus A squared. Then I'm going to move my 4A over, and it's going to become minus 4A. Then I'm going to move my 4 over, and it's going to become minus 4, and it's all equal to 0. So, this is nice. 2a squared minus a squared is a squared. 2a minus 4a is minus 2a. And plus 1 minus 4 is minus 3 is equal to 0. So we have to factor this. The fact that minus 3 is prime is going to be helpful. So it's a polynomial in a squared minus 3 and minus 2a. Well, I have no choice but to put a and a here, and minus 3 is minus 3 times 1. So minus 3a, minus 3 times a is minus 3a, 1 times a is a, minus 3a plus a is minus 2a. So I have the factorization, a plus 1 times a minus 3. So that means a plus 1 times a minus 3 is equal to 0. So that means a plus 1 is equal to 0, or a minus 3 is equal to 0. This implies a is equal to minus 1, and this implies a is equal to 3. Now here's the thing. Our a is the length of something. And we don't have an interpretation for negative length. So we throw out that answer and we say a is equal to 3. Remember that b was equal to a plus 1, so b is equal to 4, and c was equal to a plus 2, so c is equal to 5. So we have our really familiar 3, 4, 5 right triangle. One of the most famous known, and certainly the Babylonians knew about that as well as the Greeks. So, this is a really important example. So the graph of a degree 2 polynomial, f of x is equal to ax squared plus bx plus c, is a parabola. Open up or down. If the parabola crosses the x-axis, that means y is equal to 0, which means y is equal to f of x, which means f of x is equal to 0. And hence we have 0 is equal to ax squared plus bx plus c. So this is true of polynomial functions in general. Wherever it crosses the x-axis, y is equal to 0. So we're going to use this fact, where did I go, to match which graph could possibly be for which of the following polynomials. So we have f of x is equal to x minus 3 times x plus 2. So to find out the x values where it crosses the x-axis, we just set it equal to 0. So this implies x minus 3 is equal to 0, or x plus 2 is equal to 0. So this crosses the x-axis when x is equal to 3, because if x minus 3 is equal to 0, that implies x is equal to 3. And if x plus 2 is equal to 0, that implies x is equal to minus 2. So we come up here, and I see that at this graph right here, it crosses the x-axis at x is equal to minus 2 and x is equal to 3. So the answer to A is graph B. Oh, sorry. It's not problem A. So the answer to the first one is graph B. Now let's look at the second one. So again, it crosses the graph when g of x is equal to 0. So we solve 0 is equal to x, x plus 2, x minus 2. So that implies x is equal to 0, or x plus 2 is equal to 0, or x minus 2 is equal to 0. So x is equal to 0, or x is equal to minus 2, or x is equal to 2. So this is going to cross the graph at three different places. X equals 0, minus 2, and 2. And the only place that that happens is here. It crosses at 0, 2, and minus 2. So the graph for this one is C. Now we're going to check by, of course, by process of elimination, we know the last one is A, but if this were a test, it could be none of the above, or it could be a false flag. So let's go ahead and do it. C is h of x is equal to x minus 2, x plus 2, and x minus 1. So again, where it crosses the x-axis, h of x, which stands for y, is equal to 0. So I get x minus 2, x plus 2, x minus 1, and you should have no problems in solving each one of these. Set equal to 0. That implies x is equal to 2. This one implies x is equal to minus 2. And this one implies x is equal to 1. And indeed, right here at this graph, the graph of this function crosses the x-axis at x is equal to 1, x is equal to 2, and x is equal to minus 2. So it's not a false flag question. The graph for that one is A. This is a really important skill. Don't write this one off. This one should somehow stick in your head. So that's it for section 5.8, solving equations by factoring and problem solving. And that's actually all of our lectures for chapter 5. And that's the last lecture we will have before our exam on chapter 5.